Hi, a very good evening to my lecturer, Dr. Sumaya Binti Masari. We are from Group 9 and we are here to present about our BDB project, which is based on the robotic arm using the electropneumatic system. Let me introduce about myself and my team members as well. So my name is Morrison, son of K Johnson, and my metric number is CN240319, and my teammate name is Jeevesh Analaki Raman, and his metric number is CN240121, and another teammate which his name is Ahmed Muhammad Ahmed Al Adad. So his metric number is AN230140. So we are the three members did this project for our group, which is group 9.
Assalamu alaikum. This is Ahmed Al Hattad, and this is my slide. The objectives of our group project was system analysis, demonstrate the pickup and the place operation into disaggregated motion status using action sensors and the controlled signals motion and motion coordination, ensuring each pneumatic Articator operates only when uh, frequencies coordinated are safely to prevent coordination and control circuit design, and we should design an indirect pneumatic control systems to achieve our goal and timing and style control, implement the dependent and style dependent logic including gripping and ungripping delays and fix repetition system verification connection through simulation by analysis indicator movement single flow and timing using fluid sim teamwork and documentation demonstrate effective task division and decision making to produce and complete a report and functional model. Design statement goal: develop electropneumatic control for two axis pickup and place robot. Second, uh, repetitive material transfer with the sequence timing and safety rules. Operation conditions: home position, lift up sensor active, start with the dual start button, stop immediately with a stop push button. Control challenges: Coord, coordinate horizontal, vertical, and gripping motion. Each motion only when all conditions are satisfied. Use sensors delay and style counter. Design validation: use the indirect coordination with the pilot valve, prevent collision and wrong gripping. Verify using fluid sim pneumatic simulation.
Okay, so let me explain about the displacement step diagram. So basically, we are used to do it motion sequence diagram, and also motion sequence diagram. So this is a new thing I have learned through this project. Actually, this is if I'm not mistaken, it's a week 12 or week 11 theory class. So from this, I have learned again. So so the displacement step diagram is basically this. These are the format for the displacement step diagram. So let me explain how it works. So there are three cylinder. There are three cylinder we use. One is for up and down. Another second one is for grip and ungrip. Third one is left and right. So for the up and down, we use BG1 and BG2, And for the grip or ungrip is BG3, BG4, and left and right for BG5 and BG6. So as you can see, when we press the two buttons simultaneously, SF1 and SF2, it will trigger the BG1 to extend. So once it reach BG2, BG2 will uh, BG2 will make contact to uh, grip the thing load. So once it grip, the BG3 will be extend to BG4. Once it extend to BG4, it will hold for 2 seconds. So after 2 seconds, sorry, step 1 is BG1 will be extend to BG2, and step 2 is BG2 will trigger the BG3 to extend. Then step 3 is BG4. Once it reach BG4, it will hold for 2 seconds. Step 4 is after 2 seconds, it will trigger the BG2 to retract. And step 5, when it reach to it will BG1 it will trigger the BG5, and step 5 will be BG5 will be extend. And after it extend, the step 6 is it will trigger the BG1 to extend. And once it reach BG2, the step 7 will be trigger the BG4 to ungrip. Once it ungrips step 8, when it reach to the BG3, it will hold for 3 seconds. It will hold for 3 seconds. After 3 seconds, the step 9 will make contact to the BG2, which makes to retract. Once it reach BG1, it will once it reach BG1, the step 10 will make the BG6 to BG5. So step 11 is it will repeat the process for 5 counts. So it will start again from the BG1, the initial step 1. So it will be step 1 to step 11 for 5 counts. So basically when BG1 will be BG1 will go down and grip and wait for 2 seconds. Once it grip, uh, it will be in the grip mode, and after 2 seconds it will go up. Once it go up, reach the BG2, sorry, once it go up, when it reach the BG1, it will move to the BG6. What it reach BG6, which is to the right, it will move to the down, which is BG2. BG2, once it reach down, when it is BG2, it will ungrip it will be ungrip the load. So this condition it will ungrip when it at the right side, which is BG6 and BG2 activate, it will ungrip the load. So once it ungrip the load, it will wait for 3 seconds. Then the BG4 will make so the BG3 will make contact for 3 seconds. After 3 seconds, it will move upwards, which is BG1. Once it make contact to the BG1, it will trigger the uh, BG6 to move to BG5, which is to the home position. So these are the step repeat process. Once it reach, it will start again from the step 1 to step 11. So this is the displacement step diagram that we have drawn for our group project. So that's all for displacement step diagram explanation. Thank you. Hi, my name is Morrison. So I would like to explain about my group pneumatic circuit. So this is a pneumatic circuit and an electrical circuit. So let me explain about my circuit. So we are used six proximity sensor and eight relays, and also two timer on delay relay, and also one counter relay. And for the down or up, this is a down or up cylinder, and this is a grip or ungrip cylinder, and this is the left and right cylinder. So for the down or up and grip or ungrip, we have used five two-way solenoid valve, and for the left and right we have used five three-way solenoid valve. So let's see how it works. So the first condition, we have to press the two buttons simultaneously. If I press one button, it won't works. So when I press two buttons simultaneously, it will active the KF1 relay, and this KF1 relay will allow the current for the BG5. So BG5 is activated because the left and right is in the BG5 sensor. So once it activate, it will activate KF2. KF2 will activate the MB1. So the MB1 will make the cylinder to go down. So once it gone down, it will reach BG2. BG2 will BG2 will activate, and also activate and will energize the KF3. KF3 will activate MB2. So MB2 will be grip the load. Once it reach BG4, BG4 will activate the timer. So after 2 seconds, it will be make the down or up cylinder to go up way. So this will cut off the MB1 connection, and now the cylinder will go up. So once it go up, it reach BG1. So once it reach BG1, BG1 will activate KF4. Once it activate KF4, once it activate KF4, KF4 will energize the KF4 will energize the uh, K4 will energize the MB3. So why not, when in the first condition the BG1 is in the down or up cylinder is in a BG1 BG1 place. So it didn't activate the MB3 because I have added a open contact for the open contact of T1. So once it will activate the T1 only when it reaches the BG4. So in that time the BG1 will be at the BG2 position. So KF4 will be in open context. So it won't energize the MB3 unless both are in both are and activate. So once now the T1 also activate and the KF4 is activate, then it will activate the energize the MB3. MB3 will make the robot arm to move right. So once it move right and reach BG6, BG6 will activate the KF5. KF5 will make the energize the MB1, and the down or up cylinder will go down. So once it go down and reach BG2, it will ungrip the load. How it ungrip the load? So here I have cut off the current through KF6. KF6 will be energized when the when the BG2 and BG6 is in activate condition. So once it activate, it will energize the KF6. KF6 will cut the interrupt the current. So it will cut off the grip to ungrip, and this will have to be supported by latching so that it will be in ungrip condition until it reach the home position. So next, once it ungrip, it will activate. Once the ungrip, it will reach BG3. BG3 will activate the timer for 3 seconds. After 3 seconds, the robot arm will move up and move to the home position. So first it will trigger the T2 over here and cut off the current flowing to the MB1. Now the down or up will go up. Once it reach BG1, BG1 will, which is KF8. Here you can see three it has to be made three conditions, which is kf5, kf4, kf7. Kf5 is bg6. It should be in bg6 and also in uh, bg3 and also bg1. bg1, bg3 and bg6, it will activate the kf8, and kf8 will will energize them before, and now the robot arm will move to the home position and the counter will be count, and now it will start again with the second cycle. So this cycle will be run for 5 counts. So once it reach 0, to reset the count we just press this button. It will reset the counter. So that's all for the simulation part. Thank you.
Okay, so let us go to the discussion. Okay, what is the first problem? The first problem that occur to us when we're doing the simulation is the gripper ungrips briefly, then grips back. What I'm trying to mean is, let's just say this is the two axis artisan robot. Okay, so the robot it grips, but it ungrips and again it grips back. So it is not fully ungrips it. So the object not fully released at tray C. Okay, the cause is because the KF3 is not interrupted latching. Okay, so for the solution that we have done is what we want is to ungrip only when the BG2 and BG6 are active, and also activate relay contact 6. The no close contact 6 interrupts contact 3 latching. Okay, let me just explain it. The two axis Cartesian robot, it is picking up, it's gripping the load from tray A, but it's not releasing fully at tray C. So what we want is it is to grip fully and ungrip fully and stay ungrip. Okay. So after we done this, the result is the gripper fully ungrips and stay release. Okay, so for the problem two is the gripper grips object at picking position, but it releases the load before reaching tray number C. So the cause of this is because KF3 is activated by BG2 before latching, and also loss of current de-energized at MB2. Okay, so these are the problems, and let us see what are the solutions. Okay, so for the solution 2, we have added KF3 no contact as latching and keeps the KF3 and MB2 energized. As you can see, we have labeled that part. So that is the part we have done latching. And what is it we are trying to do here is the gripper of the two-axis Cartesian robot. We want the gripper to take the load from tray A, and grips until the tray C, and then only release it until the robot arm went down to the tray C, and then only release ungrips it. So by doing this modification and so on, we have achieved our goal. So the final result was the gripper remains closed until the tray C. Okay. Okay, now let us go to the conclusion. In conclusion, we have designed and simulated a two-axis electro-pneumatic pick-and-place system using indirect actuation. Okay, the system performs repetitive operation with correct sequencing, timing, and safety control, while the home position, which is start, stop, control, and safe reset, were successfully implemented in the circuit. Okay, sensors, relays, timer, and counter coordinated all three motion. Okay, the time delays and feedback prevented premature movement. We have used the fluid sim simulation and confirmed whether the operation is correct, and we have tested repeatedly. The errors in timing and sequencing were fixed through testing and modification. Okay, the project objective were fully achieved and validated through simulation, and that's all.